Next up for our transformations are dilations. So at the end of this lesson, I'm hoping you will be able to dilate figures in the coordinate plane and write their locations. Thinking about the word dilations, it's similar to dilations with our eyes. So it's spelled a little bit differently, but the idea of them can be very similar. So we're thinking when our eyes are dilated, they can be either getting bigger or smaller. It's kind of the same idea here. A dilation is when a shape is stretched or compressed by a scale factor. The pre-image and image should be scale models of one another. All parts of the original image should be proportional to the new image. So it's an exact like replica, but a different size. So what we actually do is we have a scale factor of k, then we simply multiply the x value by the k and the y value of k to get our new point. So if our point was p, then we get p prime after you're multiplying by k. That idea of being an exact replica, but just bigger or smaller, look at these figures and determine if each transformation appears to be a dilation. Looking at the first one, I hope you would say that that is not, because those are not the exact same figure, but just one is bigger or smaller. You could see where on the red one, it looks like those four are all the exact same size, but then when you got to these, it's clearly not the same size of each of those sides. What about B? B looks like it could be a transformation. It's just a bigger or smaller version of it. So you're thinking, if I take something like this, I'll try it with a different one. Or let's see if it works this way. It's okay. The point is, it looks like it's in large of the exact same size. When you get to C, I hope you're saying, no, that doesn't look like it would. And then D does look like it. When we're actually looking in the coordinate plane, we would want to plot the pre-image. So they're giving us P is -2, 1. Q is -1, -2. And R is 2, 0. So we connect those lines, or those points, and make our triangle. Looks something like that. Then they tell us under a dilation with a scale factor of 2. So what we do is we take our existing ones and we're multiplying each of those by that scale factor. So our new P prime would be -4, 2, because you multiply the x by 2 and then the y by 2. We would get -2 and -4. We would get 4 and 0. If we plot those points, there's P prime, there's Q prime, and R prime. Connect those. And we're getting something that looks like that. One thing to point out is I should be able to draw a line from P prime through P to the origin. Of course, it didn't go straight for me. I could do the same thing from R through R prime. Really struggling today. And then it can happen for Q through Q prime as well. All of those will meet in the origin. What happens when we have a scale factor of 1/2? Everything's exactly the same, except we would expect by multiplying something by 1/2, you're getting smaller values. So if I plot 0, 4 is my P, -2, -2 is my Q, R is 4, -2. Our new ones, half of 0 is 0, half of 4 is 2, half of -2 is -1, half of 4 is 2, and half of -2 is -1. So when we plot those 2 points, P prime, Q prime, and R prime, we should be getting a triangle that is exactly half the size of the original. If the scale factor of a dilation is negative, then the pre-image is also rotated by 180 degrees. So that's something to point out, that if it's less than 0, so if it's a negative number, you're multiplying it by that K, but then it ends up rotating 180 degrees as well. So on an example like this, we have our original, and we'll end up plotting each of them. So 0, 0 is R, 4, 0 is our S, 2, -2 is T, -2, -2 is your U. Looks like it's maybe some kind of parallelogram. Our new images, multiplying by -1/2, 0 times -1/2 is still 0. 4 times a -1/2 is -2, times 0 is still 0. 2 times a -1/2 is a -1. -2 times a -1/2 is a +1. And we're getting 1, 1 for that as well. If we go to plot those points, so that's where my R prime is, my S prime, -1, 1 is my T prime, and then 1, 1 is my U prime. You see an image that does look like it's half the size, but then one thing to point out, maybe take a look at, say, T prime and T. On T, it was on the lower right-hand side of the object. Now it's on the upper left. So in addition to being smaller, half the size, it got rotated 180 degrees. So like we had learned with rotations, I can actually draw a line from T to T prime, and that's going through the origin at 180 degrees. It's a straight line. Same thing works from S to S prime, straight line. U to U prime, straight line. 180 degrees, all meeting at the origin. The rest of this set of notes are all mixed practice. So we're actually going to have you work on those in teams. So once you get to this point, or whatever time I have you coming back, we will work on it together. Hopefully you're able to understand dilations is just a matter of a scale factor shrinking or enlarging different objects. See you.